Hello, today's lesson is on 6.1 integers in the Big Ideas Math textbook. And the essential question is, how can you represent numbers that are less than 0? So let's go ahead and look at some of what we're going to fill into the notes. And I want you to think about positive numbers, right? So circle positive numbers are greater than 0. They can be written either with or without a positive sign. And some examples of positive numbers could be like 5 or plus 2 or plus 50 or how about 110, right? Is if you don't see a plus sign and you don't see a minus sign, we know that it's a positive number. Now, negative numbers are less than 0 and they have to be written with a negative sign. So you can talk about negative 4, negative 100, negative 1,000, or maybe just negative 2. Then I'm going to look at a whole number line where we've got opposites, right? We've got positives and negatives. And two numbers that are the same distance from 0 on a number line, but are on opposite sides, are called opposites. What's the opposite of 0? Well, 0 is in the middle, so 0 is technically the opposite of 0. And this number line that we're looking at is called an integer number line. And integers are the set of whole numbers and their opposites. And whole numbers are on the number line below. So whole numbers are starting with this, right? These are counting numbers, 1, 2, 3, 4, 5. And then when I include 0, I think of 0 having a whole. So that is part of the whole numbers. So right here on this side, including the 0, these are all whole numbers. And then the opposites of the whole numbers are the negatives. So whole numbers are positive, and what they are not is they're not fractions and they're not decimals. But I want you to be careful and not be fooled, like if I give you a number like this. If I give you 24 as a whole number, but then I put it over 1 as a fraction, I want you to know that this is still a whole number because really it's equal to 24. However, if I did something like this, 6.5, and I put that over 1, that is not a whole number because it includes a fraction. A decimal, which is the same thing as a fraction. Okay, so now I want you to go on your notes and circle all of the numbers that you see there that are integers. And remember, they're not fractions and they're not decimals. So I was starting with what's not an integer, and I noticed that there's 0, negative 2, 3, negative 3,487, and 101. Those are all the integers in that list. Okay, so now we're going to write some positive and negative numbers, and then we're going to graph them. So if a contestant gains 250 points on a game show, that's a positive number, right? So it's an integer, and it's a positive integer. So what I want to do is I want to pick somewhere near the middle of my graph, and I put a big close circle, and I put my 250. And then I start thinking about, I wonder what other numbers I can represent on the number line. And I want to make my number line evenly spaced out. So I may count by 50s. So 250 plus 50 is 300, plus 50 is 350. So I just added two numbers in this direction, and I always like to add two numbers in the other direction, just so you can get an idea of the scale of my graph. So I'm counting by 50s. My 250 is somewhere in the middle, and then I put 5 numbers on my number line. I recommend 5 numbers just because people can tell that you know how to space out a number line correctly. Okay, so for B, it says gasoline freezes at 40 degrees below 0. I know that's a negative. So again, I'm going to start somewhere here in the middle. I'm going to put a closed circle, and I'm going to label that as negative 40. Now remember, negatives get bigger in this direction, but it's actually a smaller value. So let's say we count by tens for this graph, and I put negative 50 over here and negative 60 here. That makes this negative 30, and then over here is negative 20. So I have 5 numbers on my number line, and I put a closed circle at negative 40. That's how I graph an integer on a number line. Now I've got some OYOs that I want you to try, so I want you to pause the video and then unpause it when you're done. Okay, so 900 feet, you're climbing up, that's a positive. So I can put my closed circle there, 900. Probably want to skip count by 100s. So this will be 1,000. This will be 1,100. And then over here, I can say that this is 800 and this is 700. Okay, number 2, you have a debt. If you have a debt, that means you owe money. That means this is a negative number. So I'm going to go ahead and start with my negative number. And maybe for this one, I'll skip count by 2s. Let's see, remember that negative, this is counting down towards 0. So this is negative 22, negative 20. This would be negative 26, and this would be negative 28. And the third one says a student loses 5 citizenship points, right? That's a negative number. So I'm going to go ahead and put my closed circle, negative 5. Maybe I'll just count by 1s for this one, negative 4, negative 3, this is negative 6, and negative 7. And the last one is a savings account that earns you a positive $10. So I'm going to make my point here, put a 10. Maybe I'll skip count by 10s. So this is 20, this is 30, this is 0, this is negative 10. Okay. Now I'm going to talk to you about how you say negatives, right? We don't usually say the minus in front of it anymore. We say a negative. So this is how you use words to say that number. You say that it's either negative 4 or the opposite of 4. For B, it's negative 30 or the opposite of 30. And for C, it's the opposite of 7 or negative 7. Notice that I just turned around the negative and the opposite. It doesn't really matter which one you say. And notice that sometimes the negative is inside the parentheses, sometimes it's outside. But for D, there's a negative inside and outside. So there's actually 2 negatives. It would be kind of weird if I said negative minus 6. So usually what I say is the opposite of negative 6. But then wait a minute, that's kind of weird because the opposite of negative 6 is actually positive 6. So this number is equal to positive 6. Even though if I ask you to read it, you would say, what's the opposite of negative 6? Okay, so now we're going to try graphing again. So here is the negative 4, right? Put a negative 4 and I can just count backwards in the negative direction. And the numbers get higher even though the value gets smaller. B is negative 30. Maybe I'll skip count by 10s. This would be negative 20, negative 10. This would be negative 40 and negative 50. So this is negative 7. So we start here with a negative 7. This would be negative 6, negative 5, negative 8, and negative 9. The last one, remember I told you it's the opposite of negative 6. You can picture being on the other side of the 0, so it's actually a plus 6. So when I graph this one, I put a 6, and then maybe I could skip count by 2s. So maybe I would make this 8 and 10, and then this would be 4 and 2. So we're graphing integers on a number line. Now you can also be asked to graph 2 numbers, right? What if I ask you to graph the integer and its opposite? So I need to graph positive 3, but then the opposite of positive 3 is negative 3. So now I have 2 things I'm graphing. Same thing for B, negative 12, and the opposite of negative 12 is positive 12. So I'm going to be graphing 2 things. So now instead of starting by putting the 3 in the middle, you want to picture a number line, and I'm actually going to put 0 somewhere in the middle. Doesn't have to be the exact middle, but I need to include positive 3 and negative 3 on either side, and it has to be the same distance away from 0. So I could skip count by 3s and do 3, 6, 9. In this direction, negative 3, negative 6, negative 9. I'm going to put a closed circle at 3 and a closed circle at negative 3. Okay, for negative 12 and 12, I'm putting the 0 in the middle. And then I could skip count by 2s or 3s or even 4s. Let's skip count by 4s. So this would be 4, 8, 12. And this would be negative 4, negative 8, negative 12. So I put a closed circle on the positive 12 and the, negative 12 here. Okay, so now we're graphing integers and its opposites. And then I want you to take a look at this and figure out if you can tell me which lines have correctly graphed the +4 and the -4. There's 4 answers, A, B, C, and D. So I want you to pause it, take a minute, see if you can figure out which one is correct. So B is correct. A looks like a great number line. It's the same as B, but it has no dots, no points, right? So no points on this one. It's missing 4 and -4. Now C has points, but they're kind of floating, right? So these are floating points. Now it looks like a face. Floating points. Your points should not be floating. They should be on the number line. And then the last one, this looked really good, except for when I skipped count. 4, 8, oops, that's supposed to be a 12, and that would be 16. So they started great, but then the number line is not spaced properly. Because what you're telling me is that from here to here, it measures 4. But then from here to here, it only measures 2, and that doesn't make any sense. Okay, last part is the OYO. Pause the video, try the OYOs, then unpause. You're graphing an integer and its opposite, which means you're always going to start with 0 in the middle. Okay, so I have to graph 6 and -6. So I could count by 2s, -2, -4, -6. I put a closed circle on -6 and +6. The number 6 is -4 and 4. So I put a 0. I think I'll count by 2s again. 2, 4, -2, -4. I put a closed circle on the -4 and then the +4. So this was the original and this was the opposite. This was the original and this was the opposite. Okay, last two, -12 and 1. So I can put a 0 here. I could skip count by 6s just to make my life easier. And then this is the opposite, this is the original. And the last one, it makes sense to count by 1s. And I graph the original and then the opposite. Okay, that is graphing integers on a number line.